Hello and welcome to the third session of the Python workshop. In this session we will have a look at some of the built-in methods of strings, and we will try to put them to use in order to make a translator from DNA to RNA. You can find more information about the Python string methods by visiting this website here. The link is also included in the description of this video, and you can find a link to download this Jupyter notebook as well. So let's get started. The first method we're going to see will allow us to remove white space at both beginning and the end. So we can declare a variable, like name for example a string. We set up equals this sentence, and here we leave some white space at the beginning and at the end. And if we print a string dot strip, this is the method strip. What this will do is that it will print the sentence without the white space at the start and at the end. It will remove those. So if we got, for example, this string, it has a white space here, then a white space in the middle, and white space at the end. If we use a strip on this sentence, on this string called bstring, what the strip will do is that it will remove this one and these ones here, but it won't remove this. So let's hit run, and you can see the example here. The first one is print a string dot strip. So it removes this part here and this other part here. But on this other sentence, it kept the spaces on the middle. We can also convert between upper and lower case. So if we got this a string equals all these, which are ACTGs, which is the genetic code, but it combines upper and lower case, and we want to, for example, convert all this into lowercase, we can go on and say print a string dot lower, and we put this parenthesis here, open and close parenthesis. We're gonna convert all these nucleotides into lowercase. But if instead we use a string dot upper, open and close parenthesis, we're gonna turn the sentence into an uppercase. For example, if we got this sentence, it will be this sentence with lowercase. But if we are using upper, it will return this sentence with uppercase. So if we hit run, you can see that this gene sequence has been converted first to lowercase and then to uppercase. We can also use string methods to replace characters. For example, if we got a DNA sequence that we will declare it as a string ACTGCC, this is the one from here in lowercase, we can use the replace function, the replace method, in order to change one letter to another. So if we are converting from DNA to RNA, we would like to change the T's for use. So we will be translating the RNA, because DNA has ACTG and the RNA has AUCG. So if we simply replace using this method here, we type RNA-seq equals DNA-seq dot replace, we open the parenthesis and then type in the first character as a string. This is the character we want to replace, and this second is the character that we are replacing with. So in this case, we will be changing from T's to U's. So we will turn this DNA sequence into an RNA sequence. Then we can call the RNA sequence to see the results in the screen. But if we type it again, if we use this kind of function again, or we use a print, it's not gonna print. So if I call it 2 times, you will see that the RNA-seq is only shown 1 time. And we got this sequence here, but we removed the T's and replaced them with U's. So that's the keystone of a script to transcribe DNA sequence to RNA. And then we could make another script to translate those RNAs into proteins, into codons, and do another bunch of analysis. So in Python, we can also use one method after another. So for example, if I got this DNA sequence, which has different lower cases and upper cases, we can do a print just to place a label of what is going to happen. We're going to convert to lower first, and then we're going to replace. So we declare this RNA sequence as DNA.lower, then we put dot replace and t's to use. So if we print this RNA sequence and here we use the escape character to create a new line, it's going to print the RNA sequence and an empty new line. Then we print this other header, and what we do is we convert to upper first and then replace. So we change the value of RNA-seq and we define its values as DNA-seq.upper. Once it is transformed to uppercase, we're going to change the uppercase T to the uppercase U. And let's see what happens. If we first convert to lower and then replace, it goes okay. If we convert to upper first and then replace, it also goes okay. But here, what we can see is that the order in which we do things could be important to some extent. So for example, if we got something like this, where we got lowercase, then we got these uppercases and those t's on the uppercase. If we want to replace first and then convert to lowercase, what will happen is that we're gonna have this DNA sequence where we are trying to replace the lower t to lower u, but the trick is that we got these two uppercases here. So if we replace first, these ones are going to be left alone, and then all the rest is going to convert to lower. So what we're gonna get is these smaller t's are going to turn into u's, and these two here, they're going to turn into smaller t's because they are not going to be changed into the u's. Another example would be if we replace first and then convert to uppercase second. If we replace first from the lowercase t to the u, then these two are going to be left alone and they are not going to be converted into u's. So the rest is going to convert into uppercase, so everything is going to be uppercase except this one that is going to turn into an uppercase u, and this one here is also going to turn into an uppercase u, but these two here will be left as uppercase t. So it won't work to translate to DNA to RNA this way. So it's important in which way we use the methods in the strings. If I run the code, you can see that replacing first and then converting to lowercase gives me something that is a mixture between DNA and RNA, but it's neither of them. It's still got some errors here. And the same goes if I replace first and then convert to uppercase. I'm gonna get some errors. See, here I got U's and I got T's and I got A's and I got G's and I got C's, meaning I haven't done the job well. If I convert to lower first or to upper and then I do the replacing, these two work better. They give me the DNA properly because I homogenize the data into one way or the other. So this is one of the useful things about the string methods. Now I'm going to go ahead and I'm going to give you another example of what can we do with methods. With methods we can split a string into a list. Let's say for example I got a string called codons and I got these triplets, these three letters UUU, GCC, AUG. They are all separated by comma and a white space. So I can use this method called split, and then I open the parenthesis and put a quote mark, and inside the quote mark I put a comma. This means that it's gonna split whatever string I have here, in this case codons. Whatever I place here, it's gonna look out for the commas and it's going to break them. So if I hit run, it's gonna return this bracket here which defines a list, and I'm gonna have comma separated values which are strings. They are indicated with the quote marks. Here I got this quote mark and some space. because I have this space here. If I remove this space and hit run, the ones that I changed disappear, but this one is this one here, and this one here appears here too. Once we have split the string into a list, we can use the array property to access the different positions. So if I use codons.split by commas, I'm going to store it into a variable called codonList by using the equals, and then I print codonList number 0 and number 2. With the 0 I'm going to get the first one, and with the 2 I'm going to get the third, because remember that Python starts counting from 0 to n numbers like 0, 1, 2, 3 and so on. So now if I hit run, it's going to return 0, which is the number 1 is the 3 used, and then number 2 is going to be the third, which is this one here. We can also check if there's a specific character or not. For example, if I have this DNA sequence, I want to check if there is double T's in this DNA sequence. I will type X equals quote marks double T in DNA sequence, and then I can print this X and it's going to return true or false. So do I have double uppercase T's here? This is gonna check and it's gonna say yes, you got this thing in here. It's gonna say yes, you got this double T's in here, which is this. So when I call print of the X is going to return true. But here on the other hand, we're going to put the not before the in. So we're going to check if there is no TT in the DNA sequence. So Python is going to say X equals false, because he's going to check here and see, is there no TT here? And it's gonna see that they got double uppercase T here. So it's going to say no, false. So when I hit run, when I check if TT is in the DNA sequence, it returns true. So if I check not in the sequence, it returns false, because it's actually in the sequence. In strings, we can also use escape characters, which are very useful if we want to format. For example, let's say I want to type a text that has 2 quote marks in the middle of it, but the quote marks already define what is a string into the Python. So if I type this bar here before the quote mark, it will escape the character. So it's gonna use this one as a literal character, while it's gonna keep this one and this other one here as the programming quote marks. So this one here and this other one here that have the escape mark before, they're going to be print. Then I can also escape different letters, different combinations of this bar with letters, to use, for example, this one here to make a new line. So whenever I place it, it's gonna create a new line. So it's gonna create a new line after Python, then a new line after is, then a new line after the best, and so on. You're gonna see when I print this, when I hit run and it prints, you're gonna see it more clearly. We can also do, for example, this one here with the T, which adds a tab. So in this sentence, I'm going to put one here, right after Python is, then we're gonna have a tab, which is a space going to the right, then we're gonna have another tab here. And finally, we're going to see the carriage return. The carriage return, I'm going to place it here right before programming. I'm going to use all the time the same sentence, but changing these escape characters. I'm going to place them in different positions, and when I hit run, you will see how they work. So this one is just to add this quote marks as text inside the string, and then we go to the new line. Okay, here we got Python and then the new line. So we got this Python and then we got the new line, then is, then we got another new line here, and then we got the best, and after the best we got a new line, and then programming language here. So then we got the tabs one, Python is, and then we got the tab. which is this character here. So we got 1 and 2. And then the caret return starts right before the programming. So the sentence will go Python is the best. And here, more or less, where this G is, we should have written Python is the best, but instead we got programming language. So the caret return jumps back to the start of the line and replaces everything that finds in there with the characters that come after it. So in this case, we can only see programming language. So that will be all for today's session. I hope that you learn, and I'll see you in the next session. If you would like to see more content like this, please like, subscribe, share, and leave your comments on the video. I'll see you in the next session.